Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to solve mixed word problems, which is a topic that frequently appears on the Arithmetic Reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. Let me stress this. These mixed word problems come in two different varieties. The first one is called a value mixed word problem, and it involves dollars and cents. And the second variety is called a percent mixed word problem. And that usually involves combining two different amounts of a solution to make a blended solution. Given that these topics in and of themselves are pretty challenging, I've decided to focus today's video just on looking at these value mixed word problems. That said, I want to stress this at the beginning of this video. In order to get the most out of these videos, I strongly encourage you to work out as many of the practice problems that you see in today's video on your own. That is to say, once we get to the practice problems in this video, um, you should pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. To start, I'm going to give you an overview of what a value mixture problem is, and then we're going to work out an example together. And then after that, there's going to be 4 practice problems in this video. And let me stress this again, these problems are somewhat challenging, so you may have to watch me work out all 4 of the practice problems before this topic starts clicking in your head. So just bear in mind, this is one of the more difficult topics that I'm going to be covering on my channel. All right, so not surprisingly, I'm going to start today's video with a few definitions. And the first one says a value mixture problem involves combining 2 ingredients that have different prices into a single blend. So for example, let's say I was a business owner and I wanted to make a new blend of coffee. More specifically, I wanted to blend Brazilian coffee, which is $7 per pound, with Ethiopian coffee, which is $10 per pound. Um, I can use a value mixture problem to determine the cost of my blend of coffee. And we'll see that in just a few minutes here. But before we look at an example, I also want to mention this. The solution of a value mixture problem is based on the equation A times C equals V, where A is the amount of an ingredient, C is the cost per unit of the ingredient, and V is the value of the ingredient. So as you'll see in just a few minutes, I'm going to use A times C equals V. More specifically, I'm going to use a table to take our word problem and translate it into algebraic and numeric expressions, which I'll then use to solve the problem. So with that in mind, let's take a look at our first example here. So this first example says a coffee merchant wants to make a 6-pound blend of coffee costing $5 per pound. The blend is made using a $6 per pound grade and a $3 per pound grade of coffee. How many pounds of each of these grades should be used? All right, so again, if it's helpful, you may want to write this down. Amount times cost equals value. And what I'm going to do is I'm going to set up a table to represent the 3 things in this word problem. Notably, I'm going to represent the $3 per pound coffee, the $6 per pound coffee, and then the blend of the coffees. So let's go ahead and do that. And again, the table is going to look like this. And I strongly encourage you to set up tables for all these problems because it's going to help you keep your work organized and it's going to help you focus on the logic of the problem rather than getting bogged down with the algebra. So again, we have 3 things going on in this problem. So we're going to need 3 rows here. And up here, I'm going to put amount, cost, value. And again, this is implied. Amount times cost equals value. But you can see that this table mirrors this formula. Amount times cost equals value. All right, so let's reread the problem and start filling in this table accordingly. Uh, so the coffee merchant wants to make a 6-pound blend of coffee costing $5 per pound. Well, I'm going to put in all the problems I do in today's video, the blend in this third row at the bottom. So they want to make how much of that blend? They want to make 6 pounds of that blend, and they want it to cost $5 per pound. So I put 6 where the amount column is and 5 where the cost column is. Again, what's value? Value is A times C, so we can actually fill in V here. It's going to be 6 times 5. All right, so now let's continue reading the word problem here. It says the blend is made using a $6 per pound grade. All right, so I'm going to represent that in this first row. We know the cost of that blend is $6 per pound, but we don't know how much of it we're going to use. So I'm going to represent that with an X. So the value for this first row is 6 times X, or just 6X. All right. Now, here's where the logic of this problem comes in. So we know in total, we're going to have 6 pounds of coffee, and this $6 blend is going to account for X of those pounds. Well, that means that this $3 per pound grade of coffee is going to be 6 minus X pounds. Okay. And again, we know that that is $3 per pound. So the value here, again, it's A times C. That's going to be 3 times 6 minus X. All right, so now we've set up our table correctly. And all we have to do at this point is decide how we're going to solve for X in this case. Well, let's think about it logically. We know that the value of this blend plus the value of this blend has to equal the value of this blend. So in other words, 6x plus 3 times 6 minus x has to equal 6 times 5. By solving this, we'll know what x is, and then we can answer the question because we know this blend of coffee is x amount, and this blend of coffee is going to have 6 minus x amount. So let's go ahead and solve for x in this equation. So the first thing I want to do is take this 3 and distribute it here as well as here. So this becomes 6x plus 3 times 6 is 18. 3 times negative x is negative 3x equals 6 times 5. Well, what is 6 times 5? That is 30. All right, so let's keep working this one out. Let's combine these like terms, notably 6x and negative 3x. 6x minus 3x is just 3x. This is 3x plus 18 equals 30. Now we're just solving for x, so in other words, we want to get x by itself. So I'm going to subtract 18 from both sides. This will cross out here, leaving me with just 3x equals. And right here, we have to either do this mentally or we can work it off to the side. It doesn't really matter. So we'll do 30 minus 18 off to the side. 0 minus 8 we can't do, so we have to borrow. This becomes 2, and now this becomes 10. 10 minus 8 is 2, and 2 minus 1 is 12. So this is 3x equals 12. And finally, to get x by itself, we'll divide both sides by 3, and this will say x equals 12 over 3, or 12 divided by 3, which is 4. Again, this question wanted us to figure out how many pounds of each grades of coffee should be used. Well, pounds refers to amount, and we already figured that out over here. Again, the $6 per pound coffee was X. So X equals 4. In other words, we're going to use 4 pounds of this $6 per pound coffee. And then the $3 per pound coffee, we let be 6 minus X. We now know what X is. So this is 6 minus 4, which is 2. So in other words, we're going to use 4 pounds of the $6 per pound coffee and 2 pounds of the $3 per pound coffee. All right, so that's that one. Um, Let me stress this. It takes a lot of practice to get comfortable filling out these charts. Most of you probably followed the logic until I got to here, so just bear with me. I'm going to do 4 more examples in this video, and hopefully by the time you watch all 4 of these examples, you'll have no problem dealing with these problems. So that said, let's go ahead and move on to our practice questions. Now, if you feel confident in your ability to set up the chart and work through these problems, I strongly encourage you to try to do that on your own at this point. Again, all you're doing is setting up a chart with A times C equals V. You're filling it in based on the information that's given in the word problem, and then you're solving accordingly. All right, so that said, let's move on to these practice problems. All right, so this first practice problem says, how many pounds of chocolate worth $4.50 a pound must be mixed with 10 pounds of chocolate worth $1.50 a pound to produce a mixture worth $2 per pound? So again, if it's helpful, we should realize that we're dealing with a value mixture problem. Therefore, we're going to find that value with this formula: amount times cost equals value. Beyond that, we're going to have to make a little chart here to tackle this problem. And that chart's going to mirror this formula here. So it's going to look like this. And again, we're going to have 3 rows. And in the bottom row, we're always going to put the blended amount. Okay? So again, this is amount times cost equals value. All right, let's reread the problem and see what information's given. How many pounds of chocolate worth $4.50 a pound? All right, so that's one of our types of chocolate. How many pounds? Well, that's an unknown, so I'm going to call that X. So X pounds of chocolate worth $4.50. And we can find V. Again, V is just A times C, so that's going to be 4.5X. Must be mixed with 10 pounds of chocolate worth $1.50 a pound. So we know that amount. That's 10 pounds of chocolate at $1.50 a pound. So in this case, the value is going to be 10 times 1.5. Again, that's just 10 times 1.5, A times C, to produce a mixture worth $2 per pound. So we're told that the mixture, which is this very bottom row, is going to be worth $2 per pound. But that said, we're not told the amount of that mixture. That said, we know we're taking X pounds of the first type of chocolate, and we're going to add that to the 10 pounds of the second type of chocolate. And just like that, we were able to determine the amount of the mixture. And now we can find the value here. That's going to be 2 times X plus 10. Okay, so now let's go ahead and solve this one. Again, we're going to be looking at this value row. And again, the value of this mixture plus the value of this mixture has to equal the value of the blended mixture. So that's going to be 4.5x plus 10 times 1.5 equals 2x plus 10. All right, so again, let's go ahead and start working things out now. We have 4.5x, there's nothing to do there, plus, and let's take care of this 10 times 1.5. Again, rather than working this off to the side, you should be comfortable just moving the decimal. Again, anything times a power of 10 just shifts the decimal to the right. So 1.5 times 10 is going to shift the decimal to the right according to how many zeros there are in that power of 10. Well, in 10, there's 1 0. So I'm going to shift that decimal 1 time to the right. In other words, 1.5 times 10 is simply 15. All right, equals. And now we have to use the distributive property here to multiply this 2 by this x, and then this 2 by this 10. So let's go ahead and do that. We have 2x plus 2 times 10 is 20. All right, now we're just solving for x here. And let's go ahead and do that now. What you want to do in this case is you want to get all the x's to one side of the equation and all the whole numbers to the other side of the equation. So I'm going to start by subtracting 15 from both sides. And I'm going to do this one step at a time. 15 minus 15 is 0, so this just becomes 4.5x equals 2x. 20 minus 15 is just 5. Now let's go ahead and subtract 2x from both sides. This crosses out here, leaving you with just 5 on this side. And we should be able to do this one in our head. 4.5 minus 2. Well, what is 4 minus 2? 4 minus 2 would just be 2. Therefore, 4.5 minus 2 is just going to be 2.5x. All right, so now we're just solving for x. And in other words, we're just going to divide both sides by 2.5 to get x by itself. This crosses out, leaving you with x equals 5 divided by 2.5. Well, you should be able to do this one in your head as well. 2.5 times 2 would be 5. So x in this case is going to be 2. That said, I'll work this one off to the side just to show you what's going on here. Again, we can regard this as long division, so you can read this as 5 divided by 2.5. And if you watched my video on long division involving decimals, you'd realize that you can't have this decimal outside this division bracket. And so in light of that, you have to shift it one time to the right. And at the same time, you're going to have to shift this decimal one time to the right as well. So this is, in other words, is 50 divided by 25. 25 times 2 is 50 with no remainder. Okay, so watch that video on long division on my channel if you don't understand how to do long division with decimals. All right, so we know x is 2. And the question asks, how many pounds of chocolate worth $4.50 a pound must be mixed with 10 pounds of chocolate worth $1.50 a pound? Well, that amount is right here. Again, this x refers to the chocolate that is $4.50 a pound. So in this case, x tells us what the answer is. X is 2, so we need 2 pounds of chocolate worth $4.50 a pound. All right, so that's that one. This next question says, you mix some tea that costs $2 per pound with some cheaper tea that costs $1 per pound. You obtain 5 pounds of tea that cost $1.50 per pound. How many pounds of each type of tea did you use? All right, so this is very similar to that question we had regarding blending coffee. In this case, we're just blending tea. So if it's helpful, go ahead and jot down this. Amount times cost equals value. And we're going to make a table that mirrors this. So again, it's going to have 3 rows in it, given that we're blending 2 things together into a third thing. And if it's helpful, you can write amount times cost equals value. All right, so let's fill this in with the information that's given in this problem. You mix some tea that costs $2 per pound. Well, some tea means an unknown amount, so that's going to be x. It costs $2 per pound, so we'll put 2 there. And therefore, we can find the value of that. That's going to be 2 times x, which is the same thing as 2x. And then we mix that with some cheaper tea that cost $1 per pound. All right, so we know the cost of that is $1. But before filling in the amount here, let's go ahead and see what else is in this problem. You obtain 5 pounds of tea that cost $1.50 per pound. So again, we always put the blend in this very bottom. So that's going to be 5 pounds of the blended teas that cost $1.50 per pound. And therefore, we can find the value of this blend. Again, that's going to be 5 times 1.5. All right, the only thing we're missing is the amount of this tea that cost $1 per pound. Well, again, our blend is going to be 5 pounds in total. We know we're dealing with an unknown amount of this first type of tea. Therefore, this second amount is going to be 5 minus x. And therefore, our value here is going to be 1 times 5 minus x. Okay, now we have enough information to set up our problem here. Again, the value of this t plus the value of this t has to equal the value of this blended t. So that looks like this. 2x plus 1 times 5 minus x has to equal 5 times 1.5. Okay, let's go ahead and start simplifying this. Ultimately, our goal is going to be to solve for x. So again, we're not going to touch this 2x just yet. That said, we're going to take this 1 and distribute it here as well as here. So this becomes plus 5. 1 times negative x is just negative x equals 5 times 1.5. All right, so we'll go ahead and work that off to the side since it's multiplication involving decimals. Many of you could do it in your head, which is great, but I'm going to work this one off to the side here. We have 5 times 1.5. That is to say we're multiplying a whole number by a decimal. In order to do this, we want to shift the decimal in 1.5 one time to the right such that it becomes a whole number as well. And when you do that, the problem becomes this: 15 times 5, albeit with one decimal to shift back into the left at the end. Again, we moved it to the right here, so we'll move it back into the left over here. 5 times 5 is 25, so we're going to drop down a 5 and carry a 2. 5 times 1 is 5, plus 2 is 7. Bring our one decimal back in. So we can see 5 times 1.5 is 7.5. Again, we're solving for x in this case, so let's combine these two like terms, notably 2x and x. 2x minus x is just x, so this becomes x plus 5 equals 7.5. Again, we're solving for x, so let's go ahead and move this 5 over here via subtraction. It says x equals 7.5 minus 5. Should be able to do that in your head, but if you're not comfortable with decimals, you can always work it off to the side like this. 7.5 minus 5. All right, so 5's clearly not written as a decimal, but that said, if we put a decimal here and a 0 after it, we've now written it as a decimal. 5 minus 0 is 5. Drop down your decimal in place. 7 minus 5 is 2. So 7.5 minus 5 is 2.5. All right, so this question asks us ultimately to determine how many pounds of each type of tea did you use. Well, those are right here. Again, we used X amount of this first type of tea and 5x, 5 minus X amount of this second type of tea. So the first type of tea is just X, so that's 2.5 pounds of that. The second type of tea is 5 minus X, and we know X is 2.5, so we can plug that in. 5 minus 2.5 is 2.5. All right, so we used 2.5 pounds of this tea that cost $2 per pound. And likewise, we used 2.5 pounds of this second type of tea that cost $1 per pound to make a blend of 5 pounds of tea that cost $1.50 per pound. All right, so that's that one. All right, so this third problem says how many pounds of almonds that cost $6.50 per pound must be mixed with peanuts that cost $1.50 per pound to yield 10 pounds of mixed nuts that cost $4 per pound. Again, not surprisingly, I recommend you write this down. Amount times cost equals value. And likewise, I recommend you start setting up your chart. And we're going to need 3 rows and 3 columns here. So let's set that up. There's 1 row, 2 rows, and 3 rows. And again, we want to label this accordingly. Amount times cost equals value. All right, let's go ahead and reread this problem and fill it in accordingly. How many pounds of almonds? Well, how many is asking you to determine that amount, so it's unknown. So we're going to call that X of almonds that cost $6.50 per pound. So that's going to be 6.5. Again, we can find value by multiplying A and C. So this is going to be X times 6.5 or 6.5X. All right, so that's almonds. Must be mixed with peanuts that cost $1.50 per pound. So that's $1.50. That said, it tells us nothing about the amount of peanuts. So we're going to have to keep reading in order to figure that out. To yield 10 pounds of mixed nuts that cost $4 per pound. So those mixed nuts are the almonds plus the peanuts. There's going to be 10 pounds of those mixed nuts, and we want those to cost $4 per pound. We can find the value of the mixed nuts by doing 10 times 4, so that's 10 times 4. All right, so now we can work our way backward a little bit and figure out how many peanuts we're going to need. Again, in total, we're going to have 10 pounds of mixed nuts. We know we have X amount of almonds, so this is going to be 10 minus X amount of peanuts. Now we can figure out the value of the peanuts. That's going to be 1.5 times 10 minus X. All right, and again, now we have our table set up here. We have to realize that the value of the almonds plus the value of the peanuts has to equal the value of the blend of both of them. So that looks like this. 6.5x plus 1.5 times 10 minus x has to equal 10 times 4. All right, so let's go ahead and work on simplifying this. Ultimately, our goal is to solve for x in this case. That is to say we want to get x by itself. So let's go ahead and just copy this down, 6.5x. Then we're going to take this 1.5 and distribute it here as well as here. So this is 1.5 times 10. If you can't do that in your head, I'll work it off to the side. We have 10 times 1.5. That is to say we're multiplying a whole number by a decimal. And if you recall, the strategy to doing this is to shift the decimal such that you get rid of it. So in 1.5, we're going to shift the decimal place one time to the right such that this becomes 15 times 10. Once we work this out, we'll move that decimal back into the left. And again, when you do multiplication, the bigger number always comes on top. So 1.5 became 15, which is bigger than 10, which is why I put it on top there. So now we're going to work this out. 5 times 0 is 0. 1 times 0 is 0. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 5 is 5, and 1 times 1 is 1. Let's add these together. 0 plus 0 is 0. 5 plus 0 is 5. 1 plus nothing is 1. Bring our 1 decimal back in. So we can see 1.5 times 10 is 15. So this is plus 15. And then 1.5 times negative x is negative 1.5x equals 10 times 4. Well, 10 times 4 is 40. All right, so let's go ahead and start simplifying this. If you want, you can go ahead and combine your like terms, notably 6.5 and negative 1.5. In essence, that says 6.5 minus 1.5x. And in case you can't do that in your head, you can always do it off to the side like this. 6.5 minus 1.5. 5 minus 5 is 0. Drop down your decimal. 6 minus 1 is 5. So 6.5 minus 1.5 is just 5x. And then we have plus 15 equals 40. Now we just want to solve for x. So we want to get x's on one side of the equation and everything else on the other side of the equation. So let's go ahead and move this 15 over here. This crosses out here, leaving you with 5x equals 40 minus 15. If you can't do that in your head, you can always work it off to the side. So now we have 0 minus 5, which we can't do. We're going to have to borrow. This is going to become 3. This is going to become 10. 10 minus 5 is 5. 3 minus 1 is 2. So this is 25. Now we're just dividing both sides by 5 to get x by itself. This crosses out, leaving you with x equals 25 divided by 5 is 5. All right, so this question says, how many pounds of each of these nuts must you mix in order to have 10 pounds that cost $4 per pound? Well, again, we know our amounts are right here, and we know one of those amounts is just x, and x equals 5. So we need 5 pounds of almonds, and then to find the amount of peanuts, again, that's 10 minus x. We know x is 5, so this is 10 minus 5, and 10 minus 5 is 5. So we need 5 pounds of almonds and 5 pounds of peanuts to create a 10-pound mix worth $4 per pound. All right, so that's that one. Again, you should be able to start working on these on your own. So in light of that, I strongly encourage you to work out this last one on your own. All right, this fourth and final question says, how many pounds of chocolate worth $8 a pound must be mixed with 20 pounds of chocolate worth $2 a pound to produce a mixture of chocolate worth $6 a pound? All right, so again, if it's helpful, you can write this down. Amount times cost equals value. And in this case, you also want to make a chart to help structure your work here. And again, we're going to have 3 rows in this chart. 1 row is for the one type of chocolate, 1 row is for another type of chocolate, and the third row is going to be for the blended chocolate. And again, this is amount times cost equals value. All right, let's reread the problem and see what's given to us. How many pounds of chocolate worth $8 a pound? Well, how many pounds of chocolate is unknown, so we'll call that x. X times 8, which is going to have a value of 8x. All right, must be mixed with 20 pounds of chocolate worth $2 a pound. So that's 20 pounds at $2 per pound. So we know the value of that. That's A times C, which is 20 times 2. All right, to produce a mixture of chocolate worth $6 a pound. So we know this blended chocolate has to be worth $6 per pound. And as far as its amount goes, that's going to be x plus 20 pounds of chocolate. Therefore, we know the value of this blended amount of chocolate is going to be 6 times x plus 20. All right, again, the value of this chocolate by itself plus the value of this chocolate by itself has to equal the value of those 2 chocolates blended together. So that looks like this, 8x plus 20 times 2 equals 6x plus 20. All right, so now we're just going to solve for x in this case. So we have 8x plus 20 times 2 is 40 equals, and now we got to take this 6 and distribute it here as well as here. 6 times x is 6x. 6 times 20, well, 6 times 2 is 12. Therefore, 6 times 20 is 120. All right, so now our goal is just to solve for x. In other words, we want to rearrange this equation such that we get x's to one side of the equal sign and everything else on the other side of the equal sign. So my first step here is going to be to subtract 6x from both sides. This will cross out here, leaving you with just 120 over there. And 8x minus 6x is 2x plus 40 equals 120. Again, we want to get x by itself, so let's get rid of this 40 now. This crosses out here, leaving you with just 2x. As we can see, 2x equals 120 minus 40. If you can't do that in your head, you can always work it off to the side. So that's 120 minus 40. 0 minus 0 is 0. 2 minus 4 we can't do, so we have to borrow. This becomes 0. This becomes 12. 12 minus 4 is going to be 8, 9, 10, 11, 12. It's going to be 8. And 0 minus nothing is nothing, so this is 2x equals 80. Again, finally, we want to get x by itself, so we'll divide both sides by 2. This will cross out here. So this will be x equals 80 over 2. Again, this should be pretty easy to do mentally. 8 divided by 2 is 4, and just tack on that 0 there. All right, so we can see that x is 40. And the question wanted us to determine the amount of the $8 per pound chocolate we needed to mix with the $2 per pound chocolate to make a blend worth $6 per pound. As we can see, the amount for that $8 per pound chocolate, we represent it with just x. So x is that amount. In other words, we need 40 pounds of the $8 per pound chocolate in order to make this $6 per pound blend. All right, so that is it for this video. Admittedly, some of these problems are pretty challenging, and the only way to really get good at these is to keep practicing. So if you struggled with what I did in today's video, I'd recommend you come back another day and then try to work out the problems on your own after a day has passed. As always, you're more than welcome to leave feedback in the comment section below. If you like the content I'm creating, by all means, please consider subscribing to my channel. That always helps me out. But on that note, I'm going to go ahead and cut you loose.